Hello. In this video, I'm going to go over the objective domain of understanding media types. And so this is where we're going to talk about cables and the characteristics that we find. Mostly, we're actually going to spend most of our time on our copper cables. So some of the terminology that we're going to need to know is crosstalk, UTP, and STP. So crosstalk is any time that we have a transfer of signals between our communication channels. Crosstalk we typically use to indicate interference that comes between, like for our twisted pair cables, it'd be interference that comes between the twisted pairs, not necessarily something external. And then UTP stands for unshielded twisted pairs. So this is the cables where we have our twisted pairs of wires, and they're just covered by a plastic sheeting. There's not really any additional shielding from electromagnetic interference. And then STP stands for shielded twisted pair. And the shielded twisted pair, we can have some sort of foil or braided metal sleeve that goes around the entire cable, and that would protect the cable from EMI. Or we can even have an additional foil or shielding around each individual's pair of twisted wires, and that would help to eliminate or reduce some of the crosstalk in the cable. So as we can see, this is what our typical twisted pair wire is going to look like. See that we've got the copper conductors, and so these are wires that are typically 22 to 24 gauge wires, and you see that we have four pairs of wires, and they're paired off by color, and then they're twisted together. And this twisting, actually, the act of the physical twisting helps to eliminate some of the magnetic interference that comes by running electricity through the wire, and that twisting kind of helps to modulate that and eliminate some of it. And then we see that each one of the wires has a insulation on it, and it's usually a plastic called PVC. And then it has an outer sheath in this that covers all of the pairs together, and that again is usually made out of PVC. Here we see if we have a shielded twisted pair, so that STP, we're going to add a foil or braided shielding around all of the pairs, and then we're also going to have something called a drain wire. And that drain wire can actually be grounded out on one or both sides of the connection to help siphon off some of the EMI that might be trying to interfere with our wire. Um, Here we can see that additionally, like at a Cat 6 or Cat 7 cable, not only do we have the the shielding on around all of the pairs of wires to help reduce the EMI, but we also have the shielding around the individual pairs to help eliminate crosstalk. Because remember, crosstalk interference is actually where we have interference between the pairs of cables. So here we see we're indicating the blue and the brown pairs. So crosstalk would be where the signal that's going down the blue wire interferes with the signal on the brown wire. And so just to keep that straight, crosstalk typically refers to interference that comes inside of our twisted pair wire, whereas EMI typically indicates some sort of interference from outside of the cable. Another thing that we have to deal with copper wires is something called attenuation. And so what attenuation is if when we're using the copper wire, the copper is an electric conductor, and so the electricity flows through that wire. However, because it's not a perfect conductor, as the electricity flows through that wire, some of it's being lost, some of the power is being lost, and so there's only so far that we can send this electrical signal through the wire before it's diminished so much that we don't have enough to maintain a signal, and that's what we call attenuation. And so that's typically why we have a maximum length on our cabling, is because that has a lot to do with the attenuation that we have across that wire. We have several different categories of twisted pairs. We've got Cat 3, Cat 5, Cat 5e, Cat 6, Cat 6a, and Cat 7. Here we see these are some of the standard, the certified lengths and speeds. And basically what this is you could absolutely run a cable longer than these. And you might actually even be able to, under the ideal circumstances, get more speed out of a cable um, at a shorter length, or to get this speed out of a longer length. It's just that at each of these categories, what this is these are the lengths and speeds that they're rated for. And so basically, this is what you should be able to expect out of this cable. So we see category 3. This is not a cable that we use very much anymore, because the speed is only 10 megabits per second, which is very slow for our modern networking. That used to be a pretty good speed, but now that would be extremely frustrating to try to use that in a network. And again, the length is 100 meters. And what you'll find is most of these category lengths, they're actually rated at 100 meters. And so the category 3 is rated at 100 meters for 10 megabits per second. Our Cat 5 cable is rated at 100 meters for 100 megabits per second, and that's where we start getting into kind of more of our more modern networking speed standards. Cat 5e, E stands for enhanced, so we've got Category 5 enhanced cable. It's rated at 100 meters for 1 gigabit per second, which is 1,000 megabits per second, and that's really that would be kind of more like the standard. If you were going to be implementing wiring for a modern network, you really probably wouldn't want to go below Cat 5e. And then we've got Cat 6. Cat 6a actually has a lower rating for its top speed. We see that it's only rated at 55 meters for the 10 gigabit per second speed, but you can still run it at 100 meters for the 1 gigabit per second speed. And we see that this is really the first one where we see a break from that 100-meter mark. And if you're trying to answer a question about this in the test, they're probably going to use that 55-meter length for the Cat 6 cable. And that's just because for the highest rated speed, that's the distance that you're going. That's the longest distance that it's going to be rated for. We also have something called Cat 6A, which which gives us that 100 meters and at 10 gigabits per second, but we don't see that a lot right now. And then there's also Category 7 is starting to come in, and this gives us that full 10 gigabit per second over 100 meters. As I've said before, it would be very helpful if you would basically have this table memorized, just to understand the different categories and the speed that you can expect over that distance. These are some of the connectors that we would see on our copper twisted pair. So we see RJ11. So this has 4 pins, and this would be two pairs. This is what we would find in like a telephone cable. Notice it is only 4 pins, so that's only half of what we use in our standard Ethernet network cabling. The RJ45 is an 8-pin connector, and they're all just kind of flat. This is the standard network connector that we see on most computers. This is what we would use for our Category 3, Category 5, Category 5e, and Category 6 cabling. Beyond that, we see something called a Tera cable or a GG45. These are both going to be more, we're going to see these more like in the Cat 6A or Cat 7 networking. And the reason is part of the crosstalk issue that we have when we start getting over those gigabit speeds is actually how close the wires are in the connector. And so it's kind of hard to see in this picture, but the GG45 connector actually moves the pairs out to the corners. And so it eliminates it moves the wires further away from each other so that those pins aren't so close, and we can push more signal through that in the same amount of time. But again, the ones that you're mostly going to be responsible for knowing are the RJ11, which is our typical telephone wire, and the RJ45, which would be our standard networking cable. The advantage of using twisted pair cabling is it's very flexible. The wires are very, very thin. It's less expensive than our others than other types of wire, especially like our fiber optic cable. It's easy to work with. Again, it's very flexible. It's not very hard to terminate. It's a pretty standard cable to use, and it works with newer protocols. So we can actually use some of our newer networking protocols using our twisted pair. The disadvantages are very susceptible to electromagnetic interference, or EMI, from machinery that's close by or power cables. One source of EMI that's very common is fluorescent lighting. Because of the way that fluorescent lights generate the light, they actually generate a lot of electromagnetic noise. And so if you have network cables running close to a fluorescent light, it can actually cause a lot of problems. It's also susceptible to electricity, and with this we mean lightning strikes. So if you have this running up in an attic or a space above your drop ceiling, it could actually kind of attract a lightning strike, and it could damage a lot of your networking gear and obviously the wire itself. And then it's also susceptible to eavesdropping because there's an electric signal flowing through this copper wire that generates an electromagnetic signal. There's actually very easy ways to, without opening, without cutting or splicing into the wire, it's very easy to kind of pick up on some of the signals that are going through the wire. Some other types of wires that we have that we're just going to cover very quickly would be the coaxial cable. And the coaxial cable is actually so we have, you see we've got a mesh conductor on the outside, and then we've got an insulator, and then we have an interconductor. And what coaxial is for is like the axis of each of these conductors is the same. So if you were to take a look at this cable from the end, you would see that middle copper line, the center of that circle is the same as the center of the outside circle. So the coaxial cable we see going from inside to out, we have our interconductor, and then we have an insulator, which is very often PVC. And then typically we're going to have some sort of shielding there. And then we're going to have our mesh conductor on the outside. And then you're going to have a sheath, which is again typically PVC around the entire wire. The advantages to the coaxial cable is it's much more resistant to EMI, or electromagnetic interference, than our twisted pair cable. And it's actually very resistant to physical damage because of just the nature of the wire with that inner, it's a much thicker wire. It also, the shielding protects that inner conductor a lot better. Some of the disadvantages is it's a much more expensive wire. There's a lot more copper in that wire, and copper is usually the most expensive part of our copper wiring. It's relatively thick, which makes it a lot less flexible. So if you have tight turns or bends that you're having to make with the wire, the coaxial is not going to make it very easy. And it's also harder to install, because of the thickness of the cable and just the method that we use to terminate it. It's a little bit more difficult to use than our twisted pair wire. And then another type of cable that you are going to be responsible for knowing about is the fiber optic cable. Now the fiber optic cable, it's actually going to have a glass or plastic fiber or core that runs down the middle of it. And then it's going to have a sort of a cladding on the outside. And what this is so the glass or plastic actually will transmit light. So with the fiber optic, we're actually transmitting our signals using light instead of electricity. The advantage to that is it's practically immune to electromagnetic interference. Because it's a light signal, it actually takes a lot of magnetic or a lot of magnetic or gravitational force to move light. So the light bouncing through that cable is very, very protected from electromagnetic interference. It also can use high data transmission rates. We can send a lot more signals through light because the light actually travels faster through the cable than the electricity traveling through a copper cable. So it's very, very fast, so we can send a lot more data through this in the same amount of time. The disadvantage is fiber optic cable is very much more expensive than either our coaxial, or especially more expensive than our twisted pair copper wire. And that's also very difficult to work with. Because we're talking about light signals, it's very easy to have a problem. Like if we don't polish the end of the cable perfectly, or with sometimes even with the right angle, or the right curve, the cable just won't work, because any type of air gaps or any type of cracks in the end of that, just kind of think of it like if you're wearing sunglasses that are all scratched up, or if your windshield is scratched, you can't see through it very well, and it causes problems. And so that's the same thing with the fiber optic cable. So that was understanding media types. Hopefully that kind of sheds a little bit of light on the different types of media that we use in networking.